primary school or junior forms, we have already talked about the concept of the HCF and LCM. For example, suppose we have two numbers, 60 and 72. We have learned how to find out the HCF, that means the highest common factor, and the LCM, that means the least common multiple of these two numbers. We have learned to perform divisions like this. We continue to do division until we can find no more common factor. And then we stop here. And now we should know that the HCF is just the product of these numbers. That means that is 2 times 2 times 3, and that is 12. And then the LCM is just a product of these numbers. So we know that this one is 2 times 2 times 3 times 5 times 6. That means 360. Okay, this is just for primary school. In senior forms, we're going to learn a new way to find out the HCF and LCM. And this new way is going to be more systematic, and it will be very useful for finding out the HCF and LCM of polynomials. So let's see what new ways we can use to find out the HCF and LCM. So let's consider this example again. We have 60 and 72. Another way to find out the HCF and LCM is to make use of factorization. That means for 60, first of all, we factorize this first. This one can be factorized as 2 to the power 2 times 3 times 5. This is also known as the prime factorization of a number. And now I'm going to do something like this. I want to make this 3 to the power 1, this 5 to the power 1, and then I want to write down 5 to the power 0 here. Why do I want to do this? Because after doing this, I can compare the terms with the same base directly. I can compare their indices. That means in order to find out the HCF, I just need to pick the smallest index among these sets. For example, for base 2, I choose 2 because 2 is the smallest. For base 3, I choose power 1. For base 5, I choose power 0. So that means the value of this should be 12. And then for the LCM, I do something similar, except that this time I pick the largest index instead of the smallest. So for base 2, I will choose power 3. For base 3, I will choose power 2. For base 5, I will choose power 1. So that means the result here should be 360. So as you can see, the results are exactly the same as the ones that we found before. And this way of comparing indices is going to be very useful for finding out the HCF and the LCM of polynomials. So let's take a look at one example of polynomials. For example, let's say we have two polynomials, 8a squared b to the power 3, and the other one is 6a to the power 5 times c. Now we can use the same trick to find the HCF and LCM. First of all, we need to factorize this, and this one can be factorized as 2 to the power 3 times a to the power 2 times b to the power 3. And this one is 2 times 3 times a to the power 5 times c. And now I want to rewrite these two expressions to make them more comparable. For example, here I may add a term 3 to the power 0 here. This is the missing base 3 term. And then I have a squared here, b to the power 3 here, and c to the power 0 here. For the second one, I have 2 to the power 1, and then I have 3 to the power 1. And then I have a to the power 5, and then I need to fill up the missing base b term here. And finally, I have c to the power 1. Now after doing this, I can compare the indices directly. So I just compare the indices of the terms with the same base. And now you should know that the HCF can be easily found. So I just choose the smallest index for each base. So for base 2, I choose 1. For base 3, I choose 0. For base A, I choose 2. For base B, I choose 0. For base C, I choose 0. So that means the HCF should be 2a squared. And then for the LCM, I choose the largest indices. So for base 2, I choose 3. For base 3, I choose 1. For base A, I choose 5. For base B, I choose 3. For base C, I choose 1. So that means the LCM can be found as 24a to the power 5, b to the power 3 times c. Now let's take a look at this example and see how we should find out the HCF and the LCM of these two polynomials. So the first thing that we must do is to factorize these two expressions. So first of all, this one can be factorized as, first of all, I should take out 2y to the power 3 and then that's x squared minus 1. And this expression can be further factorized. So this is 2y to the power 3 times x plus 1 times x minus 1. And then for the second expression, we also need to factorize this. So we can first of all take out 6y. So it is x squared minus 2x plus 1. And then it can also be further factorized. And that will become 6y, x minus 1 squared. Once you are familiar with the way that we learned before, then sometimes the HCF and the LCM can be just calculated mentally. That means there is no need to write down all the things in detail. So for example, for 2 and 6 here, I already know that the HCF of these two numbers is 2. So I know that the HCF should start with 2. And then for this base y term, I choose the smallest index, that means power 1. And then for this x plus 1 term, since there is no x plus 1 term here, so that means I will choose power 0 for this base. So that means x plus 1 is not included in this HCF expression. And then for this base x minus 1, I choose power 1 because I have 1 and 2 here and 1 is the smallest. So I know that the HCF should be 2y times x minus 1. And then for the LCM, I already know that the LCM of 2 and 6 is 6, so I know that the LCM should start with 6. And then for the base y term, I choose power 3 because 3 is larger than 1. And then for this x plus 1 term, I have power 1 here and power 0 here, so I choose power 1. And then for the x minus 1 term, I have power 2 here and power 1 here, so I choose power 2. So that's how we do to find out the HCF and LCM. Basically, we just need to compare all the terms with the same base. And then for the HCF, we just choose the smallest index among this set of indices. And then for the LCM, we just pick the largest one, the largest index for each set of the terms with the same base. So if you know how to do this step by step, the first step is factorization, and then the next step is to compare the terms with the same base. And this should be straightforward enough to look for the HCF and the LCM.